Hi guys, Alok Shrivastava. So this is going to be a very interesting video. I'm going to talk to you about the CPU Affinity. What is CPU Affinity? How it's going to make your application perform better, and what is the default behavior that when you do not configure the CPU Affinity, how the machine behaves. So try to understand this. If I've got say two cores, core 0 and core 1, and I'm running an application, so certain part of the application might run on core 1 and certain part of the application might be running on core 0, something like that. Though the kernel will tries its best that it should make sure that all the part of the application will be running on a single core, but it might not succeed sometimes. So what it does, some part of the application, some threads, some processes of that application is running on core A, and certain part of the application might be running on core B. So a lot of time what happens, the kernel now is running on a process which is on core A, then it need to move on to application or the process or the thread which might be running on the core B. So it has to move from core A to core B. We call it context switching. So that's a cost to the CPU. So let's understand how the context switching, too much of context switching makes my application perform slower, and what are the differences between voluntary context switching and involuntary context switching, number 2, and how can I tune my application or instruct the kernel to run all the part of the application on a one core. We call it CPU Affinity. So let's do that again. The guy there, the Sparta, is going to do it. So let's wear our Sparta hat or helmet, I can say, not the hat, and start doing the things and configure something known as CPU Affinity. Again, let's do a war cry. Hooah!
So guys, let us try to understand what is CPU Affinity, as I was just explaining you. So the first thing that I'm going to do is to show you how many processors I have got, or the cores. So I can simply give crop cat proc CPU info, and if I do a pipe less here, I've got processor 0, 1 core, then I move down 0, 1 and 2. So consider I've got 3 cores which is assigned to my machine. So if I run a process, let's suppose I am running HTTPD. So if I give systemctl status HTTPD, so my Apache process is running. This is the PID, and there are certain others PID also. So by default, what happens, the processor or like your the kernel tries hard. It actually tries to run all the threads of a particular process on the same core or CPU, or if it is a NUMA machine, so on the same NUMA node. So sometimes it can't. So if I show you here, I have got a lot of if I show you, I give a PID of HTTPD. So these are the HTTPD processes which are running. So my kernel will tries it hard to schedule all the threads on the same processor, but as I have told you, sometimes it may not be successful. So some part of the Apache might be running on processor 0, some part might be running on processor 1 and 2. So it goes something like that. Let me try to explain it again with a picture. This is it. This is our website, and this. So say consider the navy blue one is the Apache. So what happens, the processor is running some part of the Apache here, same here, some part of Apache is running here, some part of Apache process is running here, some running here, and some are running here, like this. So it is spread across my CPUs. So this is the default behavior, though the kernel will try its hard, to run all the processes or threads related to a particular application on a single core or a group of cores, but it can be spread. So what's the problem? I don't find any problem. The problem is context switching. The problem is that if this part or this process of Apache is running here, now the process needs the help of another process which might be running on a different CPU or a different core. So it has to jump from one core to another core. So we call it context switching. It's a cost, guys. It's a cost to the server. It's a cost to your operating system. It's a cost to the CPU. Because consider it, context switching means the processor, this process was running, now it has stopped. The second process which is required by the operating system might be running on another CPU or another core. So it has to move from one core to another core. We call it context switching. So it can take a lot of your compute power, because every time whenever there is a context switch, the CPU need to remove the previous image of the process, load the new process into the memory, and then run it. Like something like you have to overwrite a file. So first you remove a file, then copy the new file, and then start doing the process. So by default you cannot control it. But what good it will be for me if I will be able to run all the processes of Apache to particular or a set of CPUs instead of spreading it across. If I am able to run it on some cores or my selected cores or one core, then there will be less chances of context switching, because every part of the Apache will be available on one core. So that makes the kernel life easy, isn't it? Currently they are spread across, or might be if one core is not able to handle it, two cores. So we call it CPU affinity. This is what I'm trying to explain you. We call it CPU affinity, and I will also show you how the context switching takes the cost. But I hope what exactly I mean by CPU affinity is clear to you. So let's move on to it. So let's see the current status, guys. I'm removing this drawings. Remove all this stuff which I have created. Let's remove this. It might take time. I can clear the screen like this. Wow. Now let's go onto my machine. So this is the machine which I am working on. So my Apache is running. So if I simply give the command systemctl, which I had already given, status httpd, it is running. So, and I will want you to install one simple application, Tuna. This might be installed on my machine, but you should install it before we proceed further. That's great. Tuna is already installed. So let me check where my threads are running. So if I give a Tuna, -t, my process name, and the P. So it shows me that these are the PIDs of Apache. See here, PID of httpd. These are the same numbers. And this process is running on this core. So they are spread across all the cores. And if you see there, this is context switching available here. 4049 times there is a voluntary context switch, and 17 times for this process it is a non-voluntary context switching. What is voluntary context switching and what is non-voluntary context switching? First we need to understand this. Voluntary context switching means, I'll give you an example. Say in my case I've got 3 CPUs, right? So let's say I've got 3 CPUs. These are my CPUs. This is something that people don't know and they don't teach in normal trainings. That is why we are here on Network Nuts. Yeah. So we have got couple of processes running here. Say 5587 is running here. Consider this as the CPU 0. Consider is at my CPU 1 and 2. This is what I had already shown you with my cat proc CPU info, right? So it is there. Now some part of my process, say my process ID 5587 is running here. Say consider it 5587. I'm just trying to explain it to you. 5587 process is running here. Then some point of time, say 7026 is running here. You can see it on in the output also. And say 7208 is also running here. 7028, sorry. Yeah. So this is the current status here. Some part of the threads are running here. Some threads are running here and some threads are running here. So by this line 5587 is the main PID. It has to switch to other CPUs 4049 times. Means the process is running here on this core, let's say. So this PID, this particular process need to switch to other CPUs. It has switched to other CPUs 4049 times. Voluntary context switch. Voluntary context switching means the process has left the CPU because it has nothing to do. The process which is running on this core has done his job, but the second process which need to be executed might be on different core. So he has left the CPU so that the other process can be loaded and or shall be taken care by the processor. So we call it a voluntary context switching, where a process leaves the CPU for another process. So this has done it 4049 times. This one has done it 392 times. So it's a big time. And what is involuntary context switching? Involuntary context switching means a process is doing something. Try to understand this. Suppose this is a process, right? And the CPU will give a fair time to every process. Consider this as the CPU. So this process is running here, but it is taking too much time to complete its job. So the processor cannot wait for this process for lifetime. After a particular time, the processor gives its attention to the another CPU while this was doing his job. That is involuntary context switching. So voluntary means when the process has done its job and it has got nothing to do. So the kernel loads another process in the memory which might be running on a different core. Involuntary context switching means process is doing something but it's taking too long. So for the meanwhile, the CPU has shifted his attention to another process which might be running on another processor. It's something like this process is waiting for the particular CPU to get finished. Oh, come on, do your job. He's waiting for it, but it's taking too long to finish. Then he might be dating another process. The CPU is like that. So that is how the context switching and non-voluntary and voluntary context switching is. Okay, so once you understood this, so this is the current story. I can also check it by another commands, like suppose I can give the PID. This is very interesting command. The main PID is 5587. So I give PID stat is the command, which I don't know if you have used. 5587 was the main process. So it shows me this much of time. These many context switching were there per second, and these many non-voluntary context switching were there. So I can check it for every PID. In 5587, I can give 7026. So okay, this process is doing no context switching, either voluntary or non-voluntary, which is good. And let me show 1027. This is doing some context switching is there per second. So the more context switching is there, more costly it is. Costly means in terms of the CPU time. The process might get slower and the clients might complained and you just cannot add on removing the RAM. Okay, add more RAM, add more RAM. Guys, the problem is not with the RAM, the problem is how the context switching is happening. And all of the part, it's something like all part of your book is not on the same table. Some pages are on table 1, some pages are on table 2, some pages are on table 3, right? So you have to move from table to table. That is a context switch. So if you have got more cores, the CPU has to do the same, right? So you can check the with the PID of state. I can check it for this one. So 7028 is good. It's not doing any context switching for now, but it can do context switching if the need arises. 7029 is not doing anything, and let me check the last one. This is also not doing. So the main PID is doing a lot of context switching because the application is spread across my 3 CPUs. You can also get this information. This is currently I am not jumping onto the solution. I'm trying to show you what context switching is and why it is costly for the CPU. You have I hope you have heard about the time command. Beautiful command. It shows you the time. So let me give you a very simple. You have heard the cal command, right? It just shows you the calendar. You have heard about the date command. But have you noticed, or do you think all of the cal command, these are again my CPUs, core 0, core 1 and core 2. So when you are running a cal command or a simple command as date, do you think all the part of the cal command will be running on the same CPU? Might be not. Might be some part of the application or the processes or the threads which are required for the cal command might be running on a different CPU. Isn't it? Now you know what are threads. So let's check it out if we are able to find it, how it works. There is this command can be very useful. USR bin time, give verbose and give your command name, whatever command you wanted to, and just I don't want the output, so I give it a dev null. This is going to be a game changer, guys. Oh, that's great. So voluntary context switching for the cal command is one time, means you normally give the cal and you got the output. Wow, it's very simple. Not that simple for the operating system. It has to switch to another core for once. That is fine, but for once, because the binary is small. So if I try to give some more complicated command, like suppose I'm trying to find something, right? Say I give the command here, same command. I give the find command. You know the find command. I'm trying to find in the whole hard disk. The type is file where the user is student, and I putting the output in the dev null. That means try to find all the files where the owner is student in my whole hard disk. Now it's a lengthy process. So the kernel will tries to keep the process to one core, but it might not be successful and will spread it across the cores. Let's see. Okay, so 7 times it has got voluntary context switching, right? And if I try to give another user, say kiosk, let's say kiosk, as the user was not present there, see, it gives me the message user is not available. So let me give a user which is available. So kiosk user is there. Wow, it's taking time. See, voluntary context switching 3 times and involuntary context switching was 120 times. Means 120 times the CPU was waiting for a process to finish, but it hadn't finished. So it has moved on to the new process that might be on a different core. And 3 times the CPU has to leave that process and has to move to the another core. So the more context switching is there, more costly it is. Another command which can be very important is the vmstat command. You can use vmstat to find out the context switching currently happening. So this is the context switching. So what I do, I will try, this is the option here. Let me open another tab and try to run some command, and we'll go back there and try to find something. Say I do a find /type file -perm 777, right? So I'm trying to get this. I put up a enter here and I do it here. See, the context switch just increased. See here, from 1182 it has gone to 7893 and then now it's coming down as the command might have got finished. Yes, command is finished. So whenever a process run, it might needs to execute the code for you which might be available on a different CPU. We call it a context switching. That is not good if you are running a heavy application like a DB server or something like that. That's not good. Okay. Then I can also find how many threads are related to my application, say Apache if it is there. So I can use it. I can use the top. Let me show it. So my process is already running. Systemctl status httpd. Yeah, 5587 is the main PID. If I run top, you have generally learned how to use the top and see all the processes with the how much memory they are consuming, which is a normal RHCSA stuff. But let's do it more. I press F here. Wow, this is something new, the field management tool, and I am interested in number of threads and th value. This is the value which I am interested in currently. This is number of threads. I want to see how many threads of Apache is running. So I'm just clearing it for now, but this is what I am interested in. So I press spacebar here, it is being selected. So currently the top is sorting it on the basis of the percentage of CPU, but I wanted to sort it on the basis of number of threads. Right? Okay. Right, so I press S here, S for sort. See here, the field changes and I do a quit. So these 81 threads of this process is running. This PID is running. 65 threads. These are the threads running for Apache, and they might be running on different cores. So now I will be jumping onto the things how to put Apache on a single core. That I want Apache. I'm instructing my operating system. Hey, do not run the Apache. Say I've got 3 cores of CPU. So I am instructing my operating system. Currently what is happening? The Apache threads are spread across multiple cores, all the cores. So that is leading to a lot of context switching, either voluntary or non-voluntary. So what I want instead of this, I want that this is my cores. These are my 3 cores currently. I want Apache application to be confined, to be limited to, one core. That's all. Everything should be running on one core so that it will be much more faster, less context switching, and my application will behave and work more efficiently. Now let's do that. Perfect, guys. So for that, what we have to do, it's very simple. I will be doing it. So I'll just repeat the command again. So to show you, currently it is spread across multiple cores. I don't want that. There is a lot of context, voluntary context switching is happening on here. So if you want to restrict application to a particular core or a set of cores, we call it CPU Affinity. How to do it? We create a drop-in file. So I go to etc systemd and system. Right. My service name is httpd. So you have to create a directory httpd.service.d. So that is a rule. The name of the service .service.d. So I have to create this. I have to go inside this directory and create a file. Now file name, guys, can be anything. It doesn't matter. But the extension should be conf. So currently I am here. I create a file, says CPU affinity.conf. It need not to be the same name. It can be any name. And just write here service and your kernel parameter CPU affinity. And say I want to bind it to my CPU 0. That means I am telling that all the threads, everything related, they say these are my 3 cores. So by giving this statement, I am instructing the kernel to, this is my CPU 0, 1 and 2. I am instructing that the HTTPD service should be binding onto the CPU 1. That is, every part, every thread, every component will be running on 1. That is more efficient, and you know why. So I just write this. It's very simple, but the configuration is very simple, but to understand the logic is very important. Now all I have to do is that I need to do a systemctl daemon reload and restart the service. Systemctl restart httpd. Now if everything is working right and I give the same Tuna command, see here, it is running on core 0. And check it out, guys, it has came down to 15, whereas before that there were 4916, approximately 5000 context switching were there. Now currently it is only 15 context switching. See it, you can imagine it, how much efficient you have just made your Apache. Everything related to the Apache is running on the same CPU Affinity. Check this value. So that is why we don't need a lot of context switching, either voluntary or non-voluntary. Look, non-voluntary will bound to happen. Voluntary will also happen, but it is doing it on the cache miss are less. So I hope you are able to understand this. Though it was slightly overwhelming, you might find it overwhelming, but you have just made, by configuring the CPU like Affinity, you have reduced the cost in terms of context switching and to the CPU to your machine, and your application will be much more effective. So that's all, guys. This is something beyond the textbooks. Keep on loving, learning Linux, and keep coming back. Till then, bye bye, take care, Godspeed, and Jai Hind.